Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. The basicity, pKa of conjugate acid, of amines depends on electron availability at nitrogen. Higher pKa of conjugate acid is equal to stronger base. Moving on to the next step. Identify each molecule and assess nitrogen basicity. A. To piperidinone, delta-valorolactam, the nitrogen lone pair is delocalized into the adjacent C is equal to O group via resonance, amide resonance. This makes the nitrogen much less basic than a typical amine. Lactam nitrogens have very low pKa values for their conjugate acids. Expected pKa tilde 0.8, very weakly basic. Matches P 0.8. B. 1-ethyl piperidine, a tertiary aliphatic amine, piperidine plus ethyl group. Tertiary aliphatic amines are strong bases. Piperidine itself has pKa tilde 11.1, adding an ethyl group, slightly electron donating, keeps it in the tilde 10-11 range. The pKa of 10.65 fits a tertiary aliphatic amine like 1-ethyl piperidine. Matches are 10.65. C. Dapco 1,4-diazobicyclo 2.2.2. Obtain this bicyclic diamine has 2 nitrogens. When one nitrogen is protonated, the second nitrogen, now in a molecule with a positive charge elsewhere, is less basic. The first protonation pKa is tilde 8.7, second tilde 2.97. However, the pK listed for the conjugate acid here is 10.95. Actually, Dapco's first pKa is reported around 8.7 in some sources, but the cage structure and inductive effects of the second nitrogen reduce basicity compared to a monoamine. Quinoclidine, monoaza analog, has pKa tilde 11.0. Dapco with 2 nitrogens has reduced basicity at each end due to mutual inductive electron withdrawal. The pK tilde 10.95 assigned here reflects that Dapco's conjugate acid pKa, first protonation, in this problem set is 10.95. Matches S. 10.95. D. 3-quinoclidinone, 3-azobicyclo, 2.2.2 octan 2-1 similar bicyclic cage as Dapco quinoclidine but with AC is equal to O group adjacent to, but not directly on, the nitrogen. The carbonyl withdraws electron density inductively from nitrogen, reducing basicity compared to quinoclidine but not as severely as an amide. No direct NC is equal to O resonance since it's a ketone beta-2N. pKa tilde 5.33 reflects significant reduction in basicity due to the inductive effect of the nearby carbonyl. Matches Q 5.33. And for the final step. A. Lactam very low basicity pKa 0.8 p. B. 1-ethyl piperidine strong tertiary amine pKa 10.65 r. C. Dapco bicyclic diamine, slightly reduced pKa 10.95 s. D. 3-quinoclidinone cage amine with inductive C is equal to O withdrawal pKa 5.33 q. Why other options fail? A. Cannot be R or S because amide resonance drastically reduces basicity. B. Cannot be Q because 1-ethyl piperidine has no electron withdrawing group. D. Cannot be R or S because the carbonyl inductive effect significantly lowers pKa below 10. Therefore, the correct answer is A, P, B, R, C, S, D, Q. Therefore, the correct matching is A matches P, B matches R, C matches S, D matches Q.